Welcome to my channel. This is Java Data Structures and Algorithms course, and today's tutorial is about implementation of priority queue that is based on array. And if you have not already subscribed to my channel, please subscribe and promote the content. Thank you. Introduction of priority queue. Priority queue is an abstract data type, abstract data structure. And priority queue is a special queue data structure that is very different from the normal queue. It is a linear data structure just like the normal queue. It maintains the order of its elements with respect to their priority. This is the feature that distinguishes it from the normal queue or an ordinary queue, because the elements are ordered with respect to their priority. The priority can be higher or lower. We can order the priority queue in ascending or descending order. So priority queue is not a FIFO, first in first out data structure like the normal or ordinary queue data structure. Serving is based on the priority of the elements. If we are implementing lower priority queue or min priority queue, the lowest priority element will be removed first or served first. If it is implemented with a higher priority or descending order queue, the higher priority element will be served first. Implementation. Priority queue can be implemented using various data structures. We can use a lot of different things to implement a priority queue. For example, we can use arrays. Arrays can be dynamic or fixed size. Dynamic arrays can grow as per need. We can use linked list. We can also use a binary heap, either min or max. Min heap will be best suited for priority queue with the minimum elements, minimum priority elements, and max queue is good for the higher priority or descending order priority queue. And we can also use binary search tree to implement the priority queue. Priority queue complexity analysis. So because there are a lot of different options to implement the priority queue, so their runtime also differs. For example, insert or enqueue function. If we are using array based implementation, best, average and worst case as we insert at the end of the array element, it is O1. So linked list base, it will be O and worst case or average case. But we can achieve O1 if we use a tail reference or the list is empty. So the new element will be inserted in O1 time. In case of binary heap or a binary search tree, the runtime will be O log n in the worst and average case. And as if binary heap or the binary tree is empty, it will be O1 runtime. This is the runtime analysis of enqueue function. Now the dequeue function. If we are implementing the priority queue using array based implementation, the runtime will be On, because in average and worst case, because on every dequeue or removal from the front of the queue, we have to shift all the elements towards left one position. So that will cost us On time, because n is the number of elements we have to shift towards left. On in case of there is only one element, because we do not need to shift any element. So it will result in O1 best time. So in case of linked list implementation, it is O1 in all cases, best, average and worst cases. Does not matter how many elements are in the linked list. So runtime of the dequeue will be O1. For heap and binary tree implementation, the runtime will be O log n, because O log n is the traversal cost of binary tree and binary heap. For average and worst cases, it is O1 if there is only one element in the queue. So the best case for the binary heap and binary tree will be O1 in case of there is only single element. Complexity analysis continued. So the peak function in arrays and linked list and heap implementation. It will cost us only O1 if we want to peek or see the first element in the set, in the priority queue. In case of binary search tree, it has the complexity of O log n. O log n is the maximum cost of traversal between the binary tree nodes. So it will be the cost of average and worst case. It can also be achieved O1 if there is only one element in the binary search tree. Whether we have one element or we have lot of elements, it is quite fast to traverse within the binary search tree. Space complexity. Space complexity is On, where n is the number of elements stored in the queue. The memory is dynamically allocated in case of the implementation of linked list, heap, or binary search tree implementation. So we do not need to worry about how many number of elements we are going to store within the priority queue. The array-based implementation can be fixed size or a dynamic size. In case of dynamic arrays, the size can grow as per requirements. That is all about priority queue. And thank you guys. Let's code. Thank you. Hello guys. Let's implement the priority queue that is based on an array. So I have created a project in NetBeans and added the following classes. This is the priority queue class that will maintain and implement the priority queue based on an array. And I wrote a simple task class that will encapsulate the task name and the priority of the task. And the tester class that we will use to test the priority queue application. So let's begin with the task. So we only need two things to keep it simple. So name of task, private string, let's say task name, and the priority, private int priority. So like 0, 1, 2, 3, 4, 5 etc. Every number is a priority of the priority of this task, and the priority queue will maintain the elements based on these priority elements, the priority of the each task. And you can use any other object or class for your implementation according to your project. So let's begin with the task. So we have this. Let's add a constructor, string name and int priority, param name of the task and priority of the task. So assign it this dot task name is equal to task name. Let me change the parameter name, task name. Okay, and also store the priority. This dot priority is equal to priority. Okay, the rest of getter and setter methods we can generate using insert code. So generate setter and getter methods for both the class fields. Okay, that is all about the task we are using to implement the priority queue. Okay, now let's implement the priority queue. So what we need is a array to store data, private task, and let's say data. Okay, and count the elements, private int count. Okay, let's write a constant to avoid atomic value. Array size, private int final int size is equal to, let's say, 100. Okay, now allocate the memory in the constructor. This data is equal to new task and size. Initialize count to 0. So this is our basic housekeeping at the time of creation of a priority queue. So now we will write the functions. Public, let's say, void enqueue, and task function to add new element into the priority queue. So this is how it will be stored into array as ascending order. So it will maintain list of tasks with order of priorities 0, 1, 2, 3 ascending order, and we serve it from the end of the array. So there will be a change in complexity. So insertion will be on or O1 if array is empty. Okay, next, public and task dequeue. Task, sorry, we don't need parameter, so it will remove the front element, remove the front element and return it. So this will, because we are maintaining a note, we are maintaining ascending order priority, so we dequeue last element from the priority queue. So complexity will be O1 always, because we don't need to shift any element from the right side towards left. Okay, now return the front element. This is only best for the priority queue, this approach. In case of normal queue, it is better to remove from the beginning of the array. So okay, now ordinary utility functions, public and size, and we return count, function to check the number of elements in priority queue. Implementation of priority queue in an array is the simplest data structure. Return number of elements. Next, public boolean is empty. Check if the priority queue is empty. Return indicate queue is empty. Okay, another function, because underlying array can be full, so public boolean is full. So we return count is equal to this dot data dot length. So if the array is full, we return true. Check that queue is full. Indicate queue is full. Now the utility function for public void grow. Increase the size of underlying array to accommodate more elements whenever it is full. Okay, so next, we do not need to return anything, so let me implement it later. Now next function, public void print, simply print the priority queue. Print the priority queue. Okay, so let's start here. So first, if this dot is empty, s out this priority queue is empty, and we return from here. Otherwise, if the queue is not empty, we will insert the, we will print the queue. So s out, start with first element, %s, and this dot data 0. Next, print f, formatted output, int I0, I is less than count I plus plus. Start with first element, second element, sf, and percentage, comma, %s. We need to use %s because we will print the string element as string. So data I dot to string. So it will handle it can handle the custom classes also. For example, task class that I am going to use to store in the priority queue, and s out and square bracket close. That's our print function. Now let's begin with grow function. Okay, now new array with double capacity. Task, let's say temp is equal to new task and count multiply by 2. So this will allocate double the memory to the temp. Copy elements for int I0, I is less than count and I plus plus, and temp I is equal to data I. Okay, now assign to data. So data is equal to temp. So this is faster than recopying elements into data from temp array. Okay, now empty function, return count is equal to 0. Okay, size function already done. Now the dequeue function. Okay, so if not empty, check if empty, if this dot is empty. So what we will do, print a message, this priority queue is empty, and return null. Okay, now if it is not empty, so what we will do, we store the tasks stored at the last element, this dot data and this dot count -1. So the last task is stored and we reduce the size. So count -. We don't need to do anything else because the garbage collection is automatically handled by the Java virtual machine. In languages like C or C++, we have to delete the element so that we can stop the leakage of memory. So we return the task. Okay, that is our dequeue function, and its complexity is O1 because we are removing from the end of the array. Now insertion, empty, just empty priority queue, store it on first index, otherwise find the correct location. Okay, now let's begin with the empty. If I think we don't need to do this, Okay, we can directly start with the searching. Okay, so we loop int idx is equal to 0 for idx is equal to count minus 1, start from the last index in the array. So next we check idx is greater than 0, sorry, greater than equal to 0, and we search as long as the new element is has the priority less than the array element has the priority greater than the task. So what we do, data idx dot get priority is greater than equal to is greater than task dot get priority. So as long as the array element starting from the end of the array has the more priority than task, we keep on iterating or shifting the elements towards right, and idx minus minus. Okay, next we will do move the elements towards right. So data idx plus 1 is equal to data idx. So we shifted the elements. Shift elements have more priority towards right, one step right. Okay, this will make a hole. So fill the hole to store new task. So we will do data idx plus 1 is equal to task and increase the size or count. So that is how we will store new task or new element or new data object with respect to the order of their priority within the priority queue. That is all for the enqueue function. So now let's add one more condition. If queue is full, if this dot is full, so we will grow the size of array. So this will be a dynamic array based priority queue implementation. So now let's test it. Okay, we create priority queue, pq is equal to new priority queue. Okay, create some task objects. So task t1 is equal to new task, let's say task 1, and its priority is, let's say, 7. Okay, the same way we can create few more tasks. Okay, now let's change the names 2, 3 and 4 and 5. Let's change the task 7 and let's make it task 2, and this one is task, let's say, 9 and 9, and we are going to have 5. Name and priority is same, 13 and 13. Let's add one more, let's say it is 3. Okay, 3. Okay, let's change their names 2, 3, 4 and 5 and 6. Okay, let's enqueue into the list. So pq dot enqueue. So t1, let's print it side by side, dot print. Okay, same way we are adding other task. So this one is 2 and 3 and 4 and 5 and 6. So T1 is task 7. So this is only task within the priority queue. So there is no difference because there is only one element. So next we inserted T2. Its priority is 2. It is less than task 1. So the order will be task 2 will be on the left side and task 7 will be on the right side, because we are maintaining priority of the elements is based on the priority in ascending order. And when we remove, the 7 will be removed first because it has more priority than the 2. So same way the order will be maintained. So after inserting all these elements, the task will be in this order. Let me write order. So order will be 2, 3, 5, 7, 9 and 13. These are priorities. Order of priorities. So let's test if our queue is maintaining the priority. Okay guys, okay, we need to write a toString function. Public string toString. Okay, return string dot format %s and let's say name priority %d. So task name and priority, and let's put it parentheses also to distinguish them from each other. Okay, so let's run it now. Okay, so here is our priority queue. So first element inserted, let me show you the code also. Here we inserted T1, it is task 7, this one. Then we insert T2, T2 is priority 2, so it comes first, and this is the last, because we are removing from the end of the priority queue, so the highest priority will be at the end of the queue, so that it will be easier and faster to remove an element with the highest priority. So same way the order of elements are maintained with respect to the priority of the elements. Okay, now once we remove, 13 will be removed first, the task with the 13, then 9 will be removed, then 7 will be removed, then 5 will be removed, then 3 will be removed, and at the end 2 will be removed. Let's check removal. While not, pq dot is empty, so s out, let's say task removed %s and pq dot dequeue. Okay, so let's run it. Okay, this is the order. Oh, let me add new line also. Okay, this is how they are removed. 13 removed first because it has the top priority, highest priority, then 9 removed, then 7 removed, then 5 removed, 3 removed and 2 removed, and loop stops when the priority queue is empty. This is how we can implement priority queue using an array. The order of the elements maintained within the priority queue is based on the priority of the elements. We can use a removal function according to our needs. Dequeue function can remove the low priority element or the high priority element. So if high priority element we can remove from the end of the array, and if you are implementing lower priority removal, then you can remove from the front of the element. If you remove from the front of the array, the complexity of the removal will be on, because we have to shift elements towards left. Thank you guys. This is the tutorial on implementation of priority queue based on an array. I hope you have learned a lot from this tutorial. If you have not already subscribed to my channel, please subscribe and promote the content. Thank you, and see you in the next video.